Hi there, welcome to the second video on reconciliation, looking at the limit of a sequence. Okay, so a couple of things we need to do from this one. Firstly, again, we're going to have to create a reconciliation from a given context. That's pretty much part of the vast majority of reconciliation questions, or the story ones anyway, that we start off being a lot of the time. Being able to identify whether a limit exists for reconciliation, being able to calculate the limit, and then being able to find an unknown within a reconciliation given a limit. Okay, so I'm just going to start quickly with two reconciliations. Uh, what I'm going to ask you to do is just work through the first five sequences, see what's happening, the first five numbers in the sequence, so U1 to U5, and see what's happening there. Okay, now, the only information I'm not giving you, which I'm going to, is that U0 is equal to 10. So just a reminder, to get U1 here, it would be 0.2 times U0, so 0.2 times 10, add 100, and then the same here. Okay, now I've just done a little bit of work behind that, but if you pause the video and try it, then we'll move on from there. Okay, now what you should have seen happening here is, as you go through, there's two different sequences here. Now, in the first sequence, you'll notice that as you go up, it gets closer and closer to 1, 2, 5, smaller and smaller increments. Okay, so if we think about that as a graph, what's happening is, as you go along the number of the sequences, you're going up higher. You go up quite fast at first, so from 10 to 102, and then it levels out, and you're getting closer and closer to 125. Okay, so there is 125. Okay, whereas in the second one, what's happening is your jumps are getting bigger and bigger, so it ends up looking like an exponential graph. It's going up bigger and bigger each time. Now, this one here, it says it converges to a limit. Okay, you can see it's approaching that. And if you get going in that sequence, what would happen is at one point, 125 would end up being your answer, and it would go in and become 125 again. Okay, so it converges to a limit of 125, whereas this diverges, it gets further and further away from, yeah, there's just nothing, it doesn't get, it just gets further and further away from each other, and it's not going to end up at one number. Okay, now the reason that happens is because of these numbers here, your A's, your numbers before the UN. Okay, if your number is a 0 point something, okay, so between, if that A is between -1 and 1, not including, so a 0 point something, it says that that has a limit. Okay, so the limit exists if that is between -1 and 1. Okay, whereas because this is bigger, it doesn't. It's just going to get bigger and bigger and bigger and bigger. Okay, so first things first, that is your first statement. Okay, a limit exists, and they love to ask about this. Okay, they love to pop this in for a wee mark. Okay, a limit exists if -1 is less than A, which is less than 1. Okay, and they will ask you to identify when and what things have a limit. Now, your limit is what happens when you put in a number and you get the same number out. Okay, so L is equal to A times L plus B. Okay, so that UN and that UN plus 1 is the same essentially, nothing changes. So I'm just going to call it L for limit. Okay, now if we rearrange this into just a single L, we can get a formula how to find that limit, so we don't have to rattle through U1 to U5 or U1 to U100 to find it, particularly if you've got a sequence that as it goes to infinity, as it works its way further and further, it might take millions of times before it gets a limit. We don't know that. Okay, so what I'm going to do to rearrange this is I'm going to collect my L's on the one side, so L minus AL is equal to B, and then take out my common factor of L so that I can just get a formula involving 1L. Okay, and then if I divide by 1 minus A, I get my limit formula. Okay, now some teachers do this a little bit differently and just get you to go from this point at every stage. I prefer just having the formula there. Okay, so to find the limit, we're going to do B divided by 1 minus A. Okay, now that will not tell us when the limit is, it just tells us what the limit will be when it reaches it. Okay, so we're just going to look at a couple of examples now. Okay, so there's your page that kind of works as a note. You've got an example there. A pesticide is used once a week to kill the control, and then talk about insects there. So what I want you to do is have a look. A, at writing the reconciliation. That's just the same thing we looked at in the last video. And B, looking at the long-term effect on the population. Okay, now that is the limit. Okay, limit is what is the long-term effect happening. Okay, so give the video a pause and give that a wee try. Okay, firstly for part A, we're killing off 80% of the insects present, so we're going to be left with 20%. Okay, so it's 20% of the number you put in, but then you're getting another 250 coming in each month. So that is your recurrence relation. Now notice there is no U naught there, but I'm not being asked to use the sequence at all. I'm not being asked what it is after 1 week or 2 weeks or whatever. I'm just being asked to get the recurrence relation, and then B is long-term effect. Okay, and the long-term effect is all about, okay, what is happening to this limit? Okay, what is happening there? So L, if L is equal to B over 1 minus A, we know that B is a number at the end, so it's 250 divided by 1 take away 0.2. Okay, and then it's just going to be, unless it's dead easy numbers, it's just going to be a calculator question, which gives you the limit of 312.5. Okay, so that is your long-term effect. Long-term effect is insects will be 312. Okay, 312 insects. That is awful grammar. Miss Leach would bar me, but I'm just going to leave it there because I can't bother going back and changing it. Okay, now last one. Okay, now that's just using the same recurrence relation, writing recurrence relation, and using that one. Okay, and it will pop up. Last one, just a little bit of turned around. Okay, a sequence is defined by recurrence relation there. Un plus 1 is equal to KO, Un plus 2K. Given that the limit in the sequence is 27, find K. So quite a standard process in terms of giving you the answer now and asking you to work backwards. Okay, so give the video a pause and look at that. Okay, so we're told what the limit is, so we know we can use our formula. The limit is B over 1 minus A. And then we can substitute in what we know. We know the limit is 27, we know B is 2K, and we know A is K. Okay, now that's your equation to solve essentially. Okay, so here fraction, you times both sides by 1 minus K, so 27 times 1 minus K is equal to 2K. Break those brackets, 27 minus 27K is equal to 2K. So 27 is equal to 29K, which means K is equal to 27 over 29, which is nice. We're expecting it to be a horrible fraction because we know that the limit has got to be between minus 1 and 1, so it's not going to be a nice number. Okay, now looking back at what we need to know again. Firstly, being able to create a recurrence relation for a given context that will appear in your exam 100% or most likely appear in your exam. Being able to identify where the limit exists, so is A between minus 1 and 1, and then lastly being able to calculate the limit. Okay, thanks for listening.